Hello, in this video we're going to do some rule recognition problems to get used to the rules. So let's get going. So sum x fx fi. So this looks like ei. We have an existential quantifier and we get rid of it and we replace the x with an I. So let's see what it says. Yes, but we have a restriction which says that the variable can't have appeared in the derivation or premises before. And so if fi hasn't, then this is a fine derivation, or excuse me, then this is a fine application of ei. So sum y gy, therefore ga. So is this ei? Looks like it is, but it's not, because a is a name. You could apply ei here, but you would have to put in a variable in the conclusion, not a name. Sum x gy gi, and we sum x gy and we infer gi. Is this ei? No, because we can only remove, we only replace variables. So there's the existential quantifier that's eliminated. And what can we, where can we put in new variables? Only variables that are bound by the eliminated existential quantifier. So the y gets replaced by an I. For that to be ei, then you have to get rid of, to replace the y, you would need a quantifier that was binding the y, and there aren't any. So ei, you can't apply ei in that way. You could apply ei and instantiate x to whatever variable you choose, and then replace all of the x's with that new variable, but what you would get then is just gy, because there are no x's to be replaced, and so nothing changes on the inside of the existential quantifier. Sum x for all y, if fy then gx. So this looks like ei. It looks like we're just replacing the x, this x here, with the j, where we get rid of this existential quantifier. And so we look for all the x's, and we find the one here. That's the only thing bound by the existential quantifier. This y is bound by the universal, and we replace the x with a j. So that looks okay. Again, with the restriction. Okay, so this is what I was talking about before. This is an okay application of ei. This existential quantifier is vacuous. It's not binding anything. It's not doing anything. It has no effect. So when we apply ei, we're really just getting rid of it. See, we have not sum x, not for all x, sum y, fz, if and only if gy, and we get sum z, not for sum y, fz, if and only if gy. So this looks like it might be qn. It's not. The reason is that this x here changes into a z there, and there is a way you could, there are other rules you could use to get from the premise to the conclusion if you applied more than one of them, derived rules, but qn by itself doesn't let you change the variable. So that x, actually, you couldn't change it to a z. Actually, you couldn't change it to a z at all. So with qn, all qn lets you do is move the negation and change it to a sum x. And then there are other rules that actually would not let you, the other rules that would let you change the x to something, to another variable, but not to a z, which I'm not going to try to explain right now. It's not worth the time. For all x, sum z, fx and gy, then sum x, hx, or gx. So let's see what's going on here. We have this universal, and we've gotten rid of it. And so if it's anything, it's going to be ui, because we're not moving negations around. So we look here, and we see this x has been replaced by an a. That looks okay. So let's see if it's ui. No, it's not. Why? Because this x, so this x here is bound by that existential quantifier. This x is bound by that universal quantifier. So when we remove the universal quantifier for ui, we have to replace all of the variables that it binds by the same term. So it binds this variable, and it binds that variable, this x in fx, and that x in gx. And so both of those have to be replaced by the same thing, but here we've replaced the x by itself, and there we've replaced the x by an a, so that's not okay. fa and some x, gx or ga. Oh yeah, okay. So here it looks like we're doing eg on the a's. Both of those a's, they're two a's, and they both get replaced by an x, and we put in some x on the front. So this looks like it's eg, but it's not. Why? Well, because when you put in a new existential quantifier, and you're generalizing, the new existential quantifier has to bind all the new variables that you've put in. So we place this a by an x and this a by an x, so that x, we get this new x and this new x. And both this new x and this new x are supposed to be bound by this existential quantifier. And this existential does bind that x, but unfortunately it doesn't bind that x because this already does. This grabs it before this can get it. And so we don't, well, we have these two new x's replacing the a's, and they're both supposed to be bound by this. They aren't, because this x is not bound by that existential quantifier. This x is bound by that existential quantifier. All right, last one. Yes, okay. So some x, if some x fx, then some y, hy, or hx. And we have this x is, looks like we've done ui and replaced this x with a b and that x with a b. So is this okay? No, it's not, for a couple of reasons. First of all, well, one problem is that this universal doesn't have scope over the whole thing. This universal is in the antecedent. So this universal doesn't have scope over that x, and so if you apply ui to it, it shouldn't be affecting this x at all. The other problem is that this is a conditional. It's not a universal. And so you can't apply ui to this whole thing at all because it's a conditional, and you can't apply ui to conditionals. If somehow you got the for all x fx by itself, then you could apply ui and you get fb. But you can't apply rules on the inside, as we know from before, so this is not okay. This by itself lets you go to that, but you can't apply the rule to the whole thing. You can't apply ui to this while it's in the antecedent. So I think those are some good rule recognition problems. We'll go ahead and do one last video and actually apply our derivation strategies in the derivations module.